Hi everyone, in today's video we're going to see a bag of words implementation using Python. There are different ways of generating vectors using bag of words because bag of words is only a vector that considers the frequency of the words. So we have different packages in Python that have that function inside them. But you can create your own if you want, but it's going to generate a lot of for loops. And usually we prefer to use the packages because they are less computational heavy. Also, this corpus is a sample removed from Reddit comments. We have here 11 phrases that we're going to consider each one of them as a comment. And we're going to create vectors for each line of comment or each comment. And we will also show a way to create the vectors of the words based on words. So we're going to have two different vectors generation here. The first one will only consider the vector of the phrases, and the words will be in the dimension of the phrases. So if we have a vector of the word kidney, for example, it will have 10 dimensions because that 11 dimensions because that's the number of comments that we have. At the same time, for the phrase, we're gonna have the number of dimensions will be the number of words in our vocabulary that we're gonna figure out how many we have in the next line of code. So first method, we're gonna use the tokenizer from Keras. First, we need to determine our vocabulary, and that's for any time we're gonna use any different vector generator. So we need to define what is our vocabulary. And always our vocabulary will come from our corpus. So we will tokenize the sentences, transforming the words into tokens. Remember that when you do text processing, you usually have this part inside your text processing algorithm or your text processing code. So if you're gonna use bag of words later, you don't need to tokenize your text. And if you're gonna do the pre-processing, the text processing before the use of the algorithm, you can stop before you tokenize because we're gonna use tokenizer to generate the vectors. So the tokenizer from Keras has already a property of creating vectors based on the frequency of the words. Like I said before, different packages have that functionality just because it's so simple to retrieve the frequency of the words that they are able to do it. So one thing it's important to use the Keras package, you have to have the TensorFlow installed in your computer. So I also put here the link for the Keras documentation, and we have to import this keras.preprocessing.text. We import the tokenizer. That's what we're gonna use. And we're gonna define our tokenizer. We're gonna call the function tokenizer from this package. And we're gonna use this to fit on text our corpus. And that already have the vocabulary right here. They have like the tokenizer.word index keys because it creates a dictionary. We're gonna have the list of the words that we have. So here we have our vocabulary with all our words, and we can generate our vectors from the tokenizer.text to matrix. The corpus that we're gonna use, it's our corpus, and the mode is count because it will count each time, every time the word appears in the text, every time the word in our vocabulary appears in that text. And then we have those vectors. We have to keep in mind that here the sequence of the vector is the same sequence of the vocabulary, okay? So if we can see here, our vocabulary and our vectors, the vectors will have the number of words in our vocabulary, that it's 93, we can see here. And they're gonna have, if I want a specific vector from the second phrase, remember that the index starts here at 0. So the vector 1 is actually the second comment, and we have here the second comment. So in the second, we see that kidney appears 2 times. So here we have kidney appearing 2 times. And you're gonna ask, like, why did I did not count the first instance of the vector? And that is an important thing when we use the tokenizer, because it will always set to 0 the first column. So the first column is just the index, and it will always contain 0. So our vector actually starts at the second instance. And if you see the length of this vector, it will show 94. But we know that we have 93 words in our vocabulary. So that's important to keep in mind. If you're going to report those vectors, you have to disconsider the first column, or at least make a note saying that the first column must be disregarded, because it contains just the index, like just an index of each line. And here, one thing that is good by using the tokenizer is that you can see the vectors of each phrase separately. The second method that we have here, it's the count vectorizer using Schuyler. That's the one that most people use because it's well known, and there is no need to tokenize before because it has inside the model, and it does the same thing, counts the frequency of the words in the vocabulary and creates vectors. So we're gonna call this model ball, like bag of words, and we're gonna fit to our corpus. So we call the count vectorizer and we fit to the corpus. Then we print our vocabulary, that it's all those words. And here it calls vocabulary and gives like an index. So that's important, so we can know, like different than Keras, that here we see that the vocabulary consider kidney the first word. Here we have kidney as the 47 because it does in a way that we have alphabetically formed the vocabulary. So that's important to know, like which word is in each position of the vector. So we know that the first word will be HDH. So 8DH. So that's the first word. Effect is the second one. So on and so forth. And here we have to get the vocabulary without the numbers, like the index of the word. We just get feature names. So we have only the words right here. And we can see here that we only have 9.2, while in the tokenizer we have 9.3. And that's very important to keep a note, because we pre-processed the corpus, but we did not take it out stop words, or we did not do like a complete text processing. And we can see here that we have the word I. And when we use the count vectorizer, we don't have the Y here. And why is that? Because the count vectorizer usually don't like words that only have one part, like I, A. It tries to take it out the stop words. So you have to keep in mind when you are using any different package, you have to go to the documentation and see what are the specifics of that documentation of that package, what they take it out, how do they use this vector creation, how they do that. So it's important for you to check it out before you start using something that you are not familiar with, or you have no idea how it works. Because if you get like those different results, you're going to say, oh, but that's wrong. So you have to know that each package will have their own features and they will generate things in a different way. So when we do the count vectorizer transform in our corpus and we get the shape of this, we see that we have 11 phrases and 92 words. So that's how our vectors will be. Like we're going to have in each line 92 dimensions, and for each word 11 dimensions. So we generate the vectors here to array. That means that we'll generate our vectors. And in this way, we can see all our vectors. They put it the dots because it's too large, but we're going to export this to a CSV file, and that's fine. And to generate until now, we have been generating only phrase vectors, right? And the word vectors are actually in the same dimension as the phrase vectors. So we are not generating like word-to-word vectors, correct? We have been only generating words into phrases. So now we're going to have to generate the word-to-word vector. And to do that, we're going to have the frequency of the word, and we create a dictionary with all the frequencies. We see here, for example, here we have, and that's one thing that noise really is a thing that does not help us. We can see here like artificial and artificial. So it should be artificial, but someone wrote it wrong. So instead of 4, we should have 5. And that's the thing when we are doing our text processing, that we have like to make sure that we are using the correct words. And that's why we try to put everything into its steamed form. Like we try to get to the root, because in that way those two words would be together. Affect and affected would be together because they have the same meaning. So we have to make sure that we do this correctly before we apply any technique to generate vectors. Okay, so after that we generate all those frequencies, we gonna generate a matrix of the vector word to word. So we're gonna have the words in the columns and the words in the rows, and we're gonna include in the diagonal all the frequency of those words. It is important to say that for bag of words, we do not consider when the words appeared with other words. Let's say that moving on, like in the next, our next videos and next techniques, we're going to start to consider the co-occurrence matrix. And what that is, instead of having only the diagonals filled with numbers, we're going to have a bunch of numbers in any columns when two words appear together. Let's say that affected appear with artificial. So here we would have how many times those words appear in the same phrase. So we're going to have to discuss this a little bit later. But for now, remember, we are generating sparse vectors. So the only thing that we're going to have as numbers is when the two words appear together. So all the other entries of this vector will be 0. We can save the vectors into a .csv file. For the NumPy, we use save text, and we can save to a CSV file. It's not a problem. And for the data frame, we use to CSV. And here we have the result. We have all the vectors and the matrix and the vectors again. So that's important because you're going to have to export your vectors to your homework. Like for your next homework, you're going to have to consider that. And also for the homework, you're going to have to Keep in mind to use the lambda function. We're gonna use, instead of a plain text, we're gonna use a data frame. So that's important to know how to retrieve the comments from the data frame that we're gonna have. Again, you will not need to tokenize because both modules already does, unless you want to create your own bag of words model, and that's fine, and that's encouraging. If you want to do it, you want to improve your skills in programming, you should do it. So for your homework, it will be basically this. You're going to have to generate vectors from using a bag of words method. It doesn't mind which technique you're going to use. You're going to have to generate the phrase vectors. So we do not want the matrix word to word, but the phrase word. So we just want the vectors like this one. Okay? So if you have any questions about the homework or about this code or about the bag of words theory, please let me know. Send me a message and we see each other next time. Bye-bye.